Good day, ladies and gents. We're doing day 5 of our EOC review. This is part 1, equilateral and isosceles triangles. Okay, so the basic gist on equilateral triangles is that, now let me zoom in a little bit. Equilateral triangles, all sides are equal. Now, if all sides are equal, that means that all the angles are equal. And if they all add up to 180 degrees, if we take 180 divide by 3, then each one has to be 60 degrees. So that's 60, 60, 60, and that is for all equilateral triangles. For all equilateral triangles, all the sides are equal, all the angles are equal, and they would all have to be 60. Now for isosceles triangle, 2 of the sides are equal. Now if these 2 sides are equal, so think about your arms being teepeed on the table, so they're like touching right here at the top. Your elbows would be right back down here. So if your arms are equal, then your elbows would also have to be equal, and vice versa. If your elbows are equal, then your arms are equal. And that's the rule for isosceles triangles. All right, so let's actually do some examples. So for this one right here, we have find x and find y. Okay, so first of all, we know that a straight line makes a rainbow of a straight line makes 180 degrees, right? So if that's true, if this is 106, then if we use our calculator, 180 minus 106, we'd be left with 74. So this is 74 degrees right here. Now, on top of that, our arms are equal, right? So if our arms are equal, then here are our elbows. And if it was sitting like this, for instance, see here are our arms. We need the table to be on the ground or horizontal. So here are arms. We would have to turn this until the table is horizontal. So here are our arms, here are our elbows. So this angle and this angle will be equal. So this angle right here would be 74. All right, so now that we have that, we just found angle Y, which is lovely. That's 74. In addition to that, we know that all the angles of a triangle add up to 180 degrees. So if they all add up to 180, 180 minus the 74 and the other 74, we'd be left with 32. So this angle right here is 32, so X is 32. And those are your final answers. So that was nice and quick, wasn't it? All right, moving on. Let's go to number 2. All right, so number 2, same basic gist here. They want angle ABC. So this is angle. That's what that symbol means. And then they want angle B because that's where the corner would be. So basically they want angle B, but I don't know if they want the right side, the left side, or the whole shebang. When I go A, B, C, so if I take my popsicle sticks, so A, B, C, oh, look at that. They want the whole shebang, don't they? They want all of this. So we want to find this angle and we want to find this angle and then put those two together. All right, so let's do that. Well, this right here, we know that these two angles right here, these two sides, they're equal. So if I turn this, if I know that these two arms are equal, I know my two elbows. This elbow and this elbow would be equal. So if this is already 72, this would also be 72. And because we know that all of a triangle adds up to 180 degrees, all right, so 180 minus 72 and 72, this leftover angle would be 36. So we have 36 so far. In addition to that, we have this other triangle. Now that triangle is equilateral. Now all the sides are equal. That means all the angles were equal. If all the angles were equal, right here, so if all of these were equal, and notice I'm putting a double angle. This one was single. I put a double angle because single was already being used, and there's no proof that these two are equal. And technically they're not, because if these 3 angles are equal, 180 divided by 3, they would each have to be 60. Or I could have just remembered that by one of the rules of equilateral triangles. All 3 angles are equal. So this is 60, 60, 60. And now finally, let's answer their question. They wanted angle A, B, C. So they want all of this right here. I'm going to show that in blue. They want all of this. This angle right here. They want all of that angle. And so that angle right there would be 36 plus 60. And if we put that in our calculator, 36 plus 60, we would get 96 degrees. And that's the answer right there, 96. All right, so on number 4 here, let's see. Ooh, I like this one. They want M and N. Now, first of all, do you see that these arms right here, they're equal to each other? Let's turn that until your elbows are on the table. So our arms, we want those up in the air. So here are our arms, and our elbows are down here. Now, to make a little more sense out of this, you might want to separate the two triangles. That might make a little more sense to you. So let's focus on that little triangle right there, just in case you're curious. All right, so that little triangle, I'll do this in blue. That little triangle right there looks like this, where we have this angle and we have double, double. And then we have this other triangle where this is 40, and then this is equal and this is equal. Okay, so let's focus on one at a time. It doesn't matter which one you focus on. Let's see. Well, this is 40, correct? And we know that this angle would be equal to this angle because those are our arms and here are our elbows. So let's think about this for a second. If this is 180 degrees minus 40, right now we have 140 degrees left over, right? So if we have so this and this have to make 140. Now both of them are the same. So we'd have to divide by 2. This would have to be 70 and this would have to be 70. So let's double check. 70 plus 70 plus 40, that equals 180, and that's the answer on that one. Now over here, how many degrees is right here? That is an actual number. How many degrees is that? Hopefully you said 90. All right, so reset this. If this is 180 and we already used 90 degrees, we have 90 degrees left over, and each one of these have to be equal. This right here would be equal to this right here, because our two arms are equal, our two elbows are equal. So if both of these have to add up to 90, then both of them have to be 45 and 45. Isn't that nice? Okay, now taking that information, let's see what we can get. All right, so we know for a fact that this angle right here is 45 on the little one. And on the big one, there's this line that's cutting in the middle of that, isn't it? Well, I don't know if it's actually in the middle. It's just cutting that. So I know that all of this from up here is 70 degrees. So all of this is 70, all of this is 70. All right, so let's think about this. If this is 45 and all of it is 70, how much is left? So let's see. So we put that in the calculator. 70, if we subtract the 45, then this little angle right here has to be 25. And this angle right here has to be 25. And 25 plus that 45 makes that 70 degrees. So I know I'm doing this right. Now we should be able to answer our question. So our question was, if I put this back and I zoom in here, okay, what was M? M was 25 and N was 45. And for this to make sense, I had to do two things. One, I had to turn my paper until it made sense. And so my elbows were on the table. And my second thing I did was separate the two triangles. By doing this simple action, that made this entire equation make more sense to me. But you do whatever floats your boat. Number 5. All right, number 5, same idea. We have our arms are equal and our elbows are on the table, so that's perfect. Okay, but here's the thing. These are not angles. So there's a lot of people who would have gone, this is wrong, by the way, wrong. A lot of people would have gone, oh, 2x minus 1 plus x plus 7. This is wrong, 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 plus x minus 4 is equal to 180. No, this is wrong. Don't do that. This right here, these are sides, not angles. They do not, no, add up to 180. It's a very, very common mistake. What we're supposed to do, these sides, these two sides are equal, so just set them correct. Set them equal to each other, and that would be the right thing to do. So we have 2x minus 1 is equal to x plus 7, and that is the correct thing to do. All right, so we're going to subtract 1x from both sides, because there's an invisible 1 right there. And we pop out with 1x minus 1 is equal to a positive 7. Add 1 to both sides, and a 1x is just an x, so that's just x equals 8. Every time we find x, what should we do? Plug it back into the picture. So when we plug that back into the picture, let's see what we get. We have 2 times 8 minus 1, and we get 15. 8 plus 7, that's 15. Oops, only works if you can see it. And then we have 8 minus 4, and that right there is 4. And these two sides were equal, so that makes us feel really good about this. Now, by plugging it back in the picture, two things happened. One, we checked ourselves. I feel really good. These were supposed to be equal, and they are. The second thing we did was to be ready no matter what they asked us. And they asked us about CB. So here's C, here's B. What is that distance? The answer was 4. So good thing to do, and that's your answer. All right, let's go to part 2. So flipping over to the next page. Okay, we are now doing classifying triangles on the coordinate plane. So we're on part 2. Fabulous. Okay, so on this one, so a couple of rules that we need to know. So one of the rules is what these mean, right? Well, let's talk about this. Acute means that all angles are less, so all the angles are less than 90. This is one angle is 90 and the other one's obtuse, but we're only given side lengths right now. So how can we do this? So let's talk about this. E for equilateral, I for isosceles, and S for scaling. Now, how many horizontal lines do you have? 1, 2, 3. So that means that 3 sides will be equal. Are equal. I'll just put an arrow right there. Okay, 3 sides are equal. On isosceles, we have 2 horizontal lines. That means 2 sides are equal. And on scaling, no, there are no horizontal sides. There's no horizontal sides on the letter S. So that means no sides are equal. So as long as all of the sides are different, then we're good. And that's for scaling. Now for acute, right, and obtuse. So here's the rules for that one. Now, do you remember a squared plus b squared equals c squared? Well, put the c in the front. If c squared is less than a squared plus b squared, it is acute. So that means that all the angles are less than, so all angles are less than 90. Okay, if c squared is equal to a squared plus b squared, that means it's a right triangle. That means one side equals 90. And finally, if c squared is greater than a squared plus b squared, that means it's obtuse, where one angle, oops, I said one side, angle, sorry about that, angle. One angle is greater than 90. All right, so those are the rules. Boom, boom, right there. All right, so those are the rules right there. All right, so if you need to take a picture of that or look at your hot topics, that's what you need to do. Go for it. All right, so here we go. All right, so this one right here. So they say to classify by the angles and classify by the sides. Now it's really easy to classify by the sides on this one. By the sides, all 3 are equal, right? So if all 3 are equal, then that right there, oops, classify by the, okay. So we know that by the sides, this is an equilateral triangle, equilateral. And there was actually one more, but it's not on here. So all 3, so check this out. Because all 3 are equal, then all this is 60, 60, 60. So technically, this is an acute triangle, but better yet, it's but that's the only choice for us is acute, correct? But another name for this would be equal angular, but that was not one of the options. But a better name for this, equal angular, sorry, would be a better choice. So equal angle. So equal angular would be a better choice for this one, but that wasn't an option. So acute is the one we're going to use. But equal angular would have been a better choice. All right, so that's by the angles. That's by the sides. All right, let's keep going. Number 2. For number 2, we have this right here. Now by the sides, how many sides are equal? None of them. So that would be scaling. And then to classify by acute, right, or obtuse. Okay, which one's the biggest one? So this would be, for small to big, this would be A, this would be B, this would be C. And we're going to plug it into here. So that would be, how does C squared, how does that compare to A squared plus B squared? So how does 8.7 squared compare to 6.1 squared plus 7.4 squared? That is the question. All right, so let's put this in the calculator. 8.7 squared. We got this number right here. So 75.69. How does that compare to 6.1 squared plus 7.4 squared? And that is 91.97. All right, so we would eat the bigger number so that the mouth is open towards the bigger number. So this right here is acute. And just looking at this, you can kind of tell that because none of these were bigger than 90 degrees. So, and that would be your answer right there. So that is acute. All right, sweet. Let's keep going. All right, so this one right here. Okay, how many sides are equal? There's 2 sides that are equal, so that would be isosceles. And then, okay, if this is A, B, C, because C is the bigger one, right? All right, so for this one, we would do, how does C squared, that's 4.5 squared, how does that compare to A squared plus B squared? So 2.5 squared plus 2.5 squared. All right, so we put that in the calculator. 4.5 squared, we get 20.25. How does that compare to 2.5 squared plus 2.5 squared? We get 12.5. We would eat the bigger number, and in this case, it is greater than, so that is obtuse. All right, let's keep going. All right, sweet. And then this one right here, we have, now there are 2 sides are equal, so this is isosceles again. All right, and then this is A, B, and then 5 radical 2. That's bigger, that's 7 point whatever, so that's C. All right, so how does C squared, so 5 radical 2 squared, how does that compare to 5 squared plus 5 squared? All right, so let's zoom in here. Zoom out. Okay, here we go. All right, parentheses. 5 radical 2. Okay, we get this number, right? Square that, and we pop out with the number 50. So how does 50 compare to 5 squared plus 5 squared? And we get 50. All right, that would be equal. And equal would be right. That would be a right triangle. All right, so the biggest gist that you need to know is know this equation right here, these equations or inequalities, depending on how you want to look at it. And then there was one extra rule, which was if A equals B equals C, then that is a equal angular. So that would be equal angular on that one. So that would be an extra thing that you want to know. But if that's not an option, we're stuck with acute. So those are all the options. All right, let's keep going. So more practice. Here we go. So over here, all right, the first thing we're going to do is we're going to plot this. We're going to plot this. I'm going to do some blue. All right, we have -7, 1, 2, 3, 4, 5, 6, 7, +1. And then that right there is W. And we have 0, -4. Now I'm going to put XY either above or below that. The number is with the Y, so that means it's on the Y axis. So -4, 1, 2, 3, 4. That's my X. And then they said 2, 1, 2, +3, 1, 2, 3. And that is my Y. All right, so we put all those together. All right, now just looking at this, none of these look like a right triangle. So, and they're all less than 90. So I'm really sure that this is an acute triangle, but no matter what, we should definitely find the distances just to double check. All right, so this one right here, that triangle, that is a 2, so 2 squared by, and I always start at the point and go towards the corner. 1, 2, 3, 4, 5, 6, 7, 8, 9. So plus 9 squared is equal to x squared. All right, so 2 squared plus 9 squared, I get 85 equals x squared. I would square root both sides, and I would just leave it like that. X equals the square root of 85. All right, that's one of the sides. Right here, I make another right triangle. That's 1, 2, so that's 2 squared. I'm going to do this over here so I'll have more room later. So 2 squared plus, that is, start at the point, go towards the corner. 1, 2, 3, 4, 5, 6, 7. So 7 squared equals x squared. 2 squared plus 7 squared, we get 53 equals x squared. Zoom in a little bit. There we go. All right, so 53 equals x squared. I would square both sides, and I would just leave it as the square root of 53 equals x. And over here, we have 1, 2, 3, 4, 5, 6, 7. Just double check that. 1, 2, 3, 4, 5, 6, 7. Yep, so 7 squared plus 1, 2, 3, 4, 5. 5 squared equals x squared. 7 squared plus 5 squared, I get 74. I would square root both sides, and I just leave it at that, square root of 74. Like, why make it pretty? We only want the names anyway. All right, all of these are different. So when we classify by the sides, that'd be the second one. They were all different, so that's scaling. And if you're curious, because I'm just looking at this, I know, so we would do, how does c squared, I'll do some blue, how does c squared compare to a squared plus b squared? So this is a, b, c, because c is the biggest one. So that would be the square root of 85 squared. How does that compare to the square root of 53 squared plus the square root of 74 squared? Now here's the awesome part. This is why we didn't simplify this earlier. The square and the square root cross out. So you're left with 85. How does it compare to 53 plus 74? So 53 plus 74, we get 85. How does that compare to 127? We would eat the bigger number, and then that is less than, so that is acute, just like I thought so earlier. And that's the answer. All right, so you would rinse and repeat for the next couple. You just keep going over and over again. So that's the basic gist of it, but I'm just going to keep going. All right, here we go. We're going to plot these points. So 1, 1, 2, 3, 4. Now, be careful. A lot of people go 1, 2, 3, 4. So be careful. So I positive 1, positive 1, 2, 3, 4. By saying positive or negative before you start counting usually saves you. So go positive 1, positive 1, 2, 3, 4. That's my x. Positive, or sorry, this is negative. So, and this is xy. So it's on the x-axis. So negative 1, 2, 3, and I go up 0. So it's right here. And that's my y. And then positive 1, 2, 3, 4, positive 1. And that's my z. All right, connect the dots. And your ID would be a good straight edge to use because everyone has their ID, correct? Yeah, everyone has their school ID. All right, so we have this. Okay, so on this one, let's go ahead and find all of our distances. And I'm going to go a little faster on this one. So, so x to y right here, that is, you ever feel like you did something wrong? Yep, that's right. All right, so 1, 2, 3, 4. So that's 4 squared. And that is 1, 2, 3, 4. It's 4 squared equals x squared. All right, so 4 squared plus 4 squared. And we got, so that's 32 equals x squared. This is square root of 32. So that right there is the square root of 32. Fabulous. Okay, and then we have right here, we have 1, 2, 3, 4, 5, 6, 7. So that's 7 squared. And that is plus 1 squared equals x squared. 7 squared plus 1 squared. And we get 50. So it's the square root of 50 equals x. Okay, and then this one right here, that is 1, 2, 3. So 3 squared plus 1, 2, 3. 3 squared equals x squared. 3 squared plus 3 squared. And we pop out with 18 equals x squared. Square both sides, you get the square root of 18 equals x. All right, so every single one of those was different, so it's definitely scaling. And now in blue, we're going to compare, so this is, the smallest one is a, this is b, and the biggest one is c. So how does c squared compare to a squared plus b squared? So that is square root of 50 squared. How does it compare to 18 squared, square root of 18 squared plus the square root of 32 squared? All right, the square root and the square cross out, so 50. How does it compare to 18 plus 32? How does 50 compare to 50? And that is equal. Now they're equal, so that right there is a right triangle. And then the 90 degrees would be right there. So I feel really good about that. Okay, let's keep going. All right, and then we're going to go to number 7. So I'm going to zoom out a little bit just in case anyone needs to take a picture. And number 7. All right, so number 7, we have -2, -1, +1, +1, 2, 3, 4, 5, -8, 1, 2, 3, 4, 5, 6, 7, 8, -4, 1, 2, 3, 4. Yep, okay. Sweet. All right, we do our little right triangles right here. Let's see, this side right here. Ooh, I put that guy in the middle, didn't I? Right. 1, 2, -1. Right there. That would be a better choice. So that is right here. 1, 2, 3, 4, 5, 6. That's 6 squared plus 1, 2, 3. 3 squared. And we got the square root of 45. All right here, this right triangle. Always start at the point. 1, 2, 3, 4, 5, 6. So 6 squared plus 1, 2, 3. That's 3 squared. And that's the square root of 45 again. And then right here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 squared plus 9 squared. That is 81 plus 81, which is 162. 162 square rooted. Fabulous. All right, so now that we have that, we have, so 2 of these sides are equal, so that's isosceles. And then I'm just looking at this. There is no right triangle, but I can see right here, that's obtuse. So that's an obtuse triangle. But just in case you're curious, this is your A, your B, your C. So if you do square root of 162 squared, how does that compare to square root of 45 squared plus square root of 45 squared? You would get 162 compared to 45 plus 45. How does 162 compare to 90? That right there is greater than, so that right there is obtuse. And the last one. All right, number 8. All right, let's plot the points. So that is -3, 1, 2, 3, +2, 1, 2, +2, +1, and -2, -3, 1, 2, 3. Use my straight edge here. All right, let's find these distances. Boop, boop. That is 1 squared plus 1, 2, 3, 4, 5 squared. That would be 25, 26. Square root of 26. And then over here, 1 squared plus 1, 2, 3, 4, 5. Oh, didn't we do that? Square root of 26 again. And then right here, we have 1, 2, 3, 4. And 1, 2, 3, 4. 1, 2, 3, 4. Yep. Plus 4 squared, which is 32. All right, that's definitely isosceles. All right, and this is your C, and this is A and B. All right, so how does square root of 32 squared compare to square root of 26 plus the square root of 26, both of those squared? We get 32 is compared to 26 plus 26. We get, how does 32 compare to 52? We would eat the bigger number, and that right there is acute. Sweet. All right, and those are the last problems. Hopefully that helped you out, and have a great and wonderful day.